Hi, everyone. Welcome back to our webinar series. Thanks for joining us today. Would like to introduce our team once more. My name is Graham Hutchinson with Nelson Irrigation, Mike Noftel, independent consultant in Washington State, Steve McCoon, Nelson Irrigation here in Walla Walla, Washington, Joe Vivier, our global support person with IRRICAD in New Zealand, and Ignacio Del Campo, our man in Chile with Nelson Irrigation. This is our webinar schedule. We're nearing the end of the schedule for this season. Today we will be talking about multiple water supplies and pumps. Please use the question and answer feature of Zoom and we will try and answer your questions. Para los asistentes de habla español, se puede hacer preguntas por el menú Preguntas y Repuestos. Trataremos de contestarlas en español. So today we will look at multiple water supplies and pumps. We will look at some of the rules that you need to apply when using multiple water supplies into one system. The design options to use. We'll go over a fixed flow, which is a new feature in version 19. And then at the end, we'll add some pumps into the system and show how pumps can be very valuable in stabilizing flows. 2 years ago, we produced a short video on multiple water supplies. It's a great video. It's about 8 minutes and it's available on irricad.com videos, and we will upload this video to the YouTube channel where we're putting the recordings of this webinar series. That video used 12 big guns as 12 zones with 2 water supplies, and it went over how to design completely independent systems, then join them into one system, and then add pumps. So it's a good video to review. Today, we will look at a different example, and this is a banana irrigation project using the Nelson S7 spinner. It has 28 valves. There will be 7 system flows. Each system flow will have a flow of about 1,108 gallons a minute, and it will be supplied by 2 wells, one 700 gallons a minute and one 400 gallons a minute. So we'll move into the IRRICAD design. And so you should now be seeing my IRRICAD screen. So here we have the design, and the zone design is complete, but the mainline design has not been done. And we can see the position of the 2 wells. I've highlighted them with black circles. And they are wells with different flow capacities and different water levels. The one in the top is 700 gallons a minute capacity, and the water level is 265 feet below the surface. And the other one has a 400 gallon a minute capacity, and the water level is 85 feet below the surface. I'm going to click on each water supply, and you can see that I've fixed the pressure at 35 psi. And when we have more than one water supply in a system, we cannot use the calculate pressure part of IRRICAD. We need to fix a pressure and at each water supply so that the system can analyze the results. And I'll look at the second water supply, and you can see that this is also fixed at 35 psi pressure. Also notice that the fixed flow fields are blank. When you're obtaining diameters, getting a design from IRRICAD, we cannot use fixed flow. That is for analyzing the system. So we have the flows fixed at 35 psi. In the design menu, I'll go to the zone design configuration just to show you that the valve pressures, downstream valve pressures, have been set to 28 psi. So with a little bit of friction loss above the valve, we will need approximately 29 psi upstream of the valve for the mainline design. So now we need to tell IRRICAD how this system is going to be run. And we're going to do that in the Assign Zones to System Flows menu. And we will say that there are going to be 7 system flows. So now we have the ability to click on the different blocks and assign them to system flows. You'll notice here that there's an option to click on both of the water supplies. This is new in version 19, and it saves having to click on the water supply icons each time. Sometimes the layout is a little bit congested and it's difficult to click on those icons, so now we can just click on them here. And so I'm going to select 4 blocks with those 2 water supplies checked and assign them to system flow number 1. Activate the system flows again, and then click on the next 4. And in this way, we will create the 7 system flows. Naturally, you could spread the blocks around, but in this case, the grower wanted to have contiguous blocks so it was easier to manage. Makes the main line a little bit more expensive, but it makes the management much easier. System flow 3. System flow 4. Move our dialog box over a little bit, activate the water supplies. System flow 5. System flow 6. And lastly, system flow 7. So we have 4 system flows with 4 blocks each. And you can see the flow is just over 1,107 gallons per minute with each system flow. And so we can save those and exit out. When we've got 2 water supplies or more than 1 water supply, you can have multiple water supplies connected to a system. The options for design are to use velocity design when you obtain pipe sizes. The LP is an option when you have 1 water supply. When you have multiple water supplies, the option is to use velocity design, and that's what we'll do now. So it's sized the pipes, and we will look at the reports to see the distribution of flows in the main line. And we'll look at the system GD report. You can see that for each system flow, this is from supply number 1, system flow 1, and this is from supply number 2 for system flow 1. The flows aren't really proportional to what we would like. We're really aiming for 700 gallons a minute from the first well and 400 from the second well. And for some of the first 3, we're close to that, but still high. And for the next 4, we're low, way too low. And it's the opposite for the second water supply. And while we could tweak the pressures to maybe reduce the pressure in water supply 1 to reduce this flow here, it would also reduce the flows here, which is not what we want. So let's have a look at the design. And for the most part, the pipe sizing is okay. This water supply obviously is going to service 700 gallons a minute here and 400 here. And this water supply will service 400 here. We still really need 1,100 gallons a minute over here. And so to get more water going this way, we need to increase these sizes. And we can see this is 6-inch, and which is probably going to be too small. Also, we've got some 10-inch pipe going up from this water supply, and because we only want 400 gallons out of here, that's probably too large. So what I'm going to do is manually change these segments of 10-inch and make them 8-inch. So we don't need 10-inch pipe coming up from here when we're only supplying 400 gallons a minute. And likewise, I'm going to change these segments here to 10-inch because they are too small. In the Change Type tool, I did select several different sizes, so I'm not going to match on the pipe size. I'm just going to change it all to 10-inch. And there we have 10-inch going across there. The next thing I'm going to do is go back into this water supply and use the fixed flow, the new fixed flow feature in version 19. And I'm going to set the flow to 700 gallons a minute. So notice when I activated fixed flow, calculated pressure came on, and the pressure that we set grayed out. It's not going to use these pressures anymore. The help notes under the release notes, the help file, has some really good notes on how to use this fixed flow. It's a sort of thing where you can fix this one and have this one variable, but you can't fix them both because if this is fixed, then it can vary this one a little bit in flow, or if this is fixed in pressure, it can vary the pressure here, which is what we're going to do. So now we have fixed the flow at this water supply, and now we're going to analyze the design. We're not going to design it again. Fixed flow can't be used to obtain pipe sizes, but we are going to analyze it. And then we will look at the reports. So again, mainline design reports and the system flow report. And we can see that now from water supply number 1, our flows are very close to 700 gallons a minute. Our pressures vary a little bit, and that's by necessity. Water supply number 2, the pressure is fixed at 35 psi, and the flow varies a little bit. But both of these are very close to what we want in terms of what the wells are capable of producing. So I think that looks like a good result, and we can go from there. So the fixed flow tool in version 19 is a really useful tool in getting to a solution fairly quickly. The method is to design by velocity, and then change one of the water supplies to fixed flow, and change some pipe sizes as you wish, and then do an analysis. If you have, say, 5 water supplies into a design, you could fix the flow on 4 of them, but one of them has to be floating. One thing to realize is that this gives you a really good solution on paper, and it gives you a design according to what you want. But the variability that we got after doing the velocity design is the potential variability that you'll get in the field. And so you need a way to fix the flow in the field. And the Nelson pressure sustaining valves or rate of flow control valves are excellent ways to do what we just did with the fixed flow option in IRRICAD. Out in the field, the sustaining valves and rate of flow control valves will help fix the flows in the wells in the field. So we've arrived at a good solution, but we haven't really taken into account the water levels in the wells, and we haven't allocated pump curves. So what we're going to do now is add a couple of pumps, and in the design menu, in the mainline menu, under pumps, I'm going to select a pump. And you really do have to study this a little bit and make sure you've got some pumps in the database that are appropriate, and if not, enter them into the database, because if you put pumps that really aren't going to operate well into the system, it's going to tell you very quickly. So for this water supply, I'm going to select the 700 gallon a minute pump, And I'm going to place it downstream of the water supply. The next thing I'm going to do is actually change the water supply a little bit. And I'm going to remove the fixed flow option, and I'm going to set the pressure, but I'm going to set it to minus 115 psi. And that, 115. And that replicates the 265-foot depth of the water level. That's equivalent to 115 psi. So the pump knows that it's got a, basically we're telling the pump artificially that it's 265 feet down in the well, and we're doing that by setting a negative pressure. Going to go to the second water supply and do something very similar. This time I will put in the 400 gallon a minute pump just downstream of the water supply. And again, I'm going to edit the water supply. And this time I'm going to tell it it's minus 50 psi, which is equivalent to about 85 psi, 85 feet of water level down in the well. And the calculate pressure option is not there, and the fixed flow option is not there. So now we can run the design again, run the analysis, not a design, an analysis. IRRICAD's going to give us some messages. Number one, it says, be careful, don't place pumps in loops. We can imagine if we pumped a pump in a loop, it would not be a good thing. It gives us a few messages with minor network imbalances, but the imbalance is decimal psi, so we're not going to worry about that. And then it's going to report to us that there are negative pipe pressures detected, which normally would be something to really watch out for, but we know that those negative pipe pressures are between the water supply and the pump, and those little pieces of horizontal pipe are actually vertical pieces of pipe going down to the water level. Now we can go to the reports and the same system duty report. And we can see that here we've got our negative pressure, minus 115 psi, which is equivalent to 265 psi below ground level. And we can see that our flows vary a little bit. The pump curve that was used to create the pump in the database is replicated mathematically, and IRRICAD knows it has to stay on that curve, and it does that with each water supply, and that's what restricts it. We haven't restricted the flow with the fixed flow option. We're restricting the flow by making IRRICAD stay on the pump curve for each of those pumps, and it's done that very well. So that's a really good tool. And again, that works with, it can work with single water supplies, or it can work with multiple water supplies. Not just two, it can work with more water supplies. Another report that I find useful with any mainline design is the mainline summary report. And this report shows us what we need upstream of the valve. Remember, the downstream required pressure was 28 psi, and according to the friction loss through that valve, we need 28.88 upstream of the valve. And this is what is arriving. So we've got a margin over what we need, and these are the flows here, 706.9 and 400.7. These are the flows that are coming off both pumps. And with the flows coming off those pumps and the points on the pump curves, this is the pressure that's arriving at the valves for system flow number 1. For system flow number 2, let's look at number 3. The flows are a little bit different on the pumps. Pressures are a little bit different because the distances and the friction losses are a little different. But you can see for each of these system flows, the things are balanced pretty well. The flow off each pump is fairly consistent, and we've got good pressure, marginally above what we need on each valve for each system flow. So that's a fairly quick overview of how to do multiple water supplies using velocity design, then fixing the flow, which is a new feature in version 15, and then on top of that, adding pumps and making IRRICAD stay on those pump curves for both pumps. There's quite a lot of information just presented there in a short period of time, so I recommend we will have this webinar uploaded within a day or two. I'd recommend watching it again and watching the video that we did a couple of years ago on multiple water supplies. So that's what we have for today. You're welcome to answer any questions and we'll try and answer them. But if there are no further questions, we'll...
Graham, one was asked in Spanish as far as when would the link be sent, so you may want to answer that one in Spanish as well,
okay.
verbally.
So Steve said a question was asked in Spanish when we will upload the link. La grabación va a estar disponible dentro de un día, creo que. Dentro de un día, 2 días, vamos a poner las grabaciones en el link para ver a través el canal de YouTube.
Great. And Graham, another question that came in about the 85 feet of water depth versus 50 PSI. Is that, that's the whole question. So I'm not exactly sure.
Okay, I'll go back and share the design. So 85 feet, if I did my math correctly, is in head is equivalent to 50 psi, and so if we look at the water supply, IRRICAD doesn't give us the option of putting a pressure there in feet, or a better way to put it, for the design that I'm doing, I've got my units of pressure set to PSI. And so because I want to see sprinkler pressure and pipe pressure and PSI. So I translated 85 feet of depth to the water level to PSI and put that in there in terms feet to PSI.
Great, Graham, and sort of relating to that is when you're creating these pump curves and you've created them specifically that you labeled your pumps for 700 gallons per minute or 400 gallons per minute, is there a range that would be appropriate for those pump curves in the database that it's not so specific perhaps in the label that could be used in a variety of pump flows and pressures somewhere along the curve of a pump?
Sure. Let me open up my database and I will share that. So now we should be seeing my database, and on the top there is the pump for 400 gallons a minute. And I put 400 gallons a minute at 85 PSI, which is the best duty point for that pump. So it gives you an idea. Down below, you have the option of putting a minimum flow and maximum flow. And that's a really good idea to put in the database. And so if you do use that pump where it's not applicable, let's say your flow is 800 gallons a minute, you'll get when you try and run the analysis, IRRICAD will give you a message that that pump is outside its range. So for each pump, it's good to have a minimum flow and maximum flow. The minimum flow is useful because you really don't want to run a pump well back on its curve. it's not a good thing for the pump, and you don't want to run it too far down the curve because the potential to cavitate is strong, and you may get in trouble with the NPSH requirements.
So having a label that maybe gives you a range would be fine.
We could put in a label there, and I think I have room. We could put in 150 to 550
Something like that.
GPM. You could put that in the label to help. Yeah.
Great. There's a lot of questions coming in, actually, Hutch. A question here, if we can take a couple more. I
Sure.
have not heard from the lecture consideration of the area contour profile.
Okay. So in this particular design, the elevation was flat. And let me show you the design again. So in this particular design, there was no elevation. This is on the coastal area of Guatemala, and that area is fairly flat. And so we didn't take elevation into account in this design. If we did have contours, they would have been included, or elevation information. That information would have been included in the analysis, both of the sizing of the pipes and in the analysis using the pumps.
Great. And there's actually two more that are really the same, though, in regard to friction loss in the pipe column coming up the pipe of the well.
Okay, that's a good question. And the pump curve is taken directly off the information from the pump manufacturer. And so it doesn't include any headworks loss or friction column loss in the anything that goes on in terms of friction loss from the water level to the main line. If that's a significant situation, it may be a good idea to go into miscellaneous hydraulic and select something that has a friction loss that you can put in there. You know, I could put in a 4-inch gate valve or something like that, and put it downstream of the pump, between the pump and that first junction.
Does adding additional negative pressure to your pump, could you do that to help accommodate or account for some of the?
That's a very, very good option, Steve. If you think there's another 10 feet equivalent of loss in that whole system, then you could put the depth of you could put the pressure at minus 125 instead of 115. That's a really good way of adding a margin.
Okay. The last one, if we'll save this one for a future webinar, maybe next season, but it's a person asking for more topographic information in a banana example. They've not familiar with any flat banana plantations, so look forward to seeing some with elevations. Yeah.
Yeah. Yep. Okay.
Great work. Thank you, Hutch.
Okay. Well, thank you, everyone, and I'll share my PowerPoint one last time. And move to the very last slide, and to introduce the next webinar, which will be on Tuesday the 9th, and it will be on IRRICAD Link, which is the version of IRRICAD that runs inside of AutoCAD or BricsCAD. And so we'll give you a demonstration of that. The capabilities of IRRICAD Link are identical to the capabilities of IRRICAD Standalone, but you do have the host of features that IRRICAD and BricsCAD provide. So most of that webinar will be going over the whole environment rather than the actual tools within IRRICAD. But I'll show you some example designs and some of the key differences between Link and standalone. So thanks very much for joining us today, and we will see you on Tuesday.